All right, I wanted to give you some help on problem number one. You did not see one like this in homework, but I'm glad we saw it on the test. And I will try to dig up a few more problems for you to try like this. It's really not that bad once you see what's going on. It requires working in the other direction though. So we have, for what value of k, if any, will y equals k sine of 5x plus 2 cosine of 4x be a solution to the differential equation y double prime plus 16y equals negative 27 sine of 5x. Alright, so the first thing that I want to note is that y prime in the world of differential equations is the same thing as dy dx. And so y double prime is the same thing as the second derivative. Okay? So when you see this y double prime, you can just think the second derivative of what we started with. So on this problem, what we really have to do is, instead of working backwards and integrating like we have been, we're going to work forwards from this to this. So let's get started. If I have y equals k sine of 5x plus 2 cosine of 4x, the derivative of that is dy dx. So dy dx, okay, just following the chain rule, the derivative of the sine of 5x would be the cosine of 5x times 5. So that means this is going to be 5k cosine of 5x. This is not going to be plus, this is going to be minus, because the derivative of cosine is negative sine. So we want to use a minus here, and that will turn into minus 8 sine of 4x. Alright, because the derivative of cosine is negative sine, then we've got to do the chain rule, multiply by the 4, that gets multiplied by the 2. But we're working with the second derivative, so we need to find the derivative of the derivative. So, the second derivative of this, kind of following the same plan, the derivative of cosine is negative sine. Using the chain rule, times 5 makes this be negative 25k sine of 5x minus 32 cosine of 4x. Okay, the derivative of sine is cosine multiplied by the 4. Alright, so now we have the second derivative, which is the same thing. We're wanting to know, okay, what we want to do now is we want to set this thing equal to our expression for y double prime. Alright, so let's get a new screen here. And we had that y double prime, and I'm going to use the same notation that I was using. We had that this plus 16y equals negative 27 equals negative 27 of the sine of 5x. Okay, so if I subtract 16y from both sides, alright, I now have that d squared y dx squared is equal to negative 27 of the sine of 5x minus 16y. So look what I have here. I have this expression, and I have this expression that are both equal to the second derivative. So I can set them equal to each other. And that's what we're going to do. We're going to set this thing equal to this thing, and that will allow us to solve for k. So on the right side over here, I'm going to put this one, negative 27 sine of 5x minus 16y. And on the right side, I'm going to put the other one that I had, this negative 25k business here. So that's negative 25k sine of 5x minus 32 cosine of 4x. And believe it or not, it gets better. So here's the next trick. Okay, I'm just going to recopy this side. There's nothing I need to do on this side right now. It just stays the same. But the next trick is noticing this y right here. Well, I had an expression for y at the beginning, right here. So what we're going to do is we're going to put that in for y. Alright, so let's do that. The rest of it stays the same. Negative 27 sine of 5x minus 16 times k sine of 5x plus 2 cosine of 4x. Okay, so this thing looks really bad, but it actually cleans up pretty quick in the next couple steps. So look what I've got now. Let's go ahead and get this thing cleaned up and get to our answer. Negative 25k sine of 5x minus 32 cosine of 4x equals negative 27 sine of 5x minus 16k sine of 5x minus, we've got to do distributive property now, 32 cosine of 4x. Now, this thing looks really painful, but it's really not that bad, and we got to know what we're looking for. I want to know what k is. That was the whole point of the problem. So look how quickly this thing cleans up now. If I add 32 cosine of 4x to both sides, they both go away. Boom, gone. And now I can add, I'm going to take this thing over here to get all the k's together. So I'm going to add 16k sine of 5x to both sides. Add 16k sine of 5x. On this side they go away. And on this side, the only thing I have now is negative 9k sine of 5x equals negative 27 sine of 5x. And right here is my k that I want. Alright, so this is the same thing as k times negative 9 sine of 5x equals negative 27 sine of 5x. And if I'm trying to find k, all I got to do is divide both sides by negative 9 sine of 5x. Divide this side by negative 9 sine of 5x. The sine of 5x's go away, and I'm left with k equals 3. So the reality of this problem is that it requires moving from the original equation to the second derivative, and then setting these two different expressions for the second derivative equal to each other, and doing some algebra. It does involve a lot of writing, but if you know what you're doing, you could probably get this problem done in about 5 minutes or so. I'm going to try to find a couple of these to give you as part of today's assignment so you can practice this type of situation just a couple more times. And I'm going to assign this and some AP classroom work. And we'll stop there for today.